Good evening. In continuation of our discussion on ellipse and hyperbola, this session I want to convey the extended basic format of hyperbola. We already know the standard basic form is x square by a square minus of y square by b squared equal to 1. Well, this is the basic case when the center is at origin. In the extended basic, the center gets shifted to the point with coordinates h, k. So what happens to the equation? It gets modified. X minus h the whole square over a square minus of y minus k whole square by b squared equals 1. In this case, the center is h, k, and try to understand the transverse axis parallel to x-axis and the conjugate axis parallel to y-axis. So in this case also all the other formulae, E is c by a, c square is a square plus b square, length of latus rectum twice b square by a, all of them remain constant. What the location of vertices, location of foci and equation of directrices, they get modified. So what happens to the foci? F1 and F2, because the transverse axis is parallel to x, y coordinate doesn't change. So h add c units and subtract c units from h. So you get the modified, let me just for better understanding. So the center h, k, vertex a and a dash, focus h plus c, k on the other side, it's going to be h minus c, k. And equation of directrices will be x equal to h plus or minus a by e. So h, from h you move positive a by e or you go to the left minus a by e units, we get the location of the directrices. So this is how they get modified. Vertices, what about vertices? A is h plus a, k, and the other vertex h minus a, k. So these are we call vertices. The transverse axis ends alone we call vertices. Fine. So the other case, when the transverse axis becomes parallel to y-axis, then it has to be y minus k the whole squared over a squared minus of x minus h the whole squared by b squared equal 1. So in such case, the center h, k and vertices a dash will be no change in h, x coordinate, but the y coordinate gets modified as k plus c and k minus c by moving c units above center, by moving c units below the center. So that's the way we get, I'm sorry, I made a mistake. You get by adding c units, you get foci f1 and f2. To get vertices, the ends of major, minor, so h comma k plus a, h comma k minus a. So the ends of transverse axis, that's called vertices a dash, h comma k plus a, h comma k minus a. And the location of directrices in this case will be y is equal to k plus or minus a by e, instead of x is equal to h plus or minus a by e. Done. So the other terms, the length of latus rectum 2b square by a remains constant, c by a is eccentricity remains fixed, and c squared is a square plus b square. These expressions will remain unchanged whether it is for the standard basic or whether extended basic, irrespective of the type, whether transverse axis parallel to x axis or parallel to y axis also. Well, let us discuss the geometry part of it by taking up a question. There is an equation of hyperbola given like this: 9x squared minus of 16y squared negative 36 x plus 96 y and minus 252 is 0. So 9x squared minus of 16y squared minus 36x plus 96y minus 252. So first collect the like terms, x terms. So 9 times x square minus 36. So therefore minus 4x comes after taking 9 common factor. And to collect y terms, I am taking 16 common factor also, and what is left over is y squared, and out of 96 I have taken negative 16. So what is left is negative 6y, and I am leaving some space and completing the parenthesis. Constant negative 252 I am transposing to the RHS to make it positive 252. Now students know what we are going to do here. Take the coefficient of x, which is 4, negative 4, make it half of it, minus 2, square it also, square and add, that gives plus 4. But by adding 4, what we have done is we have added 9 times 4. So we have added 36. So let us add 36 on RHS. And here coefficient of y is negative 6, half of it is negative 3, square it, you get 9. Okay. So by adding 9, what I have done is 9 times minus 16, that means I have subtracted 144. So I do the same subtraction on RHS also. So what is you get, what is it you get after completing the square? X minus 2 the whole squared, negative 16 times of y minus 3 whole squared. RHS, this becomes 288 minus 144. So balance is 144. Now let us divide everywhere by 144. I get 9 times of x minus 2 whole squared by 144. 16 times of y minus 3 whole squared by 144 to make RHS 1. So you can see that we are arriving at the standard form x minus h whole squared by a square. So here 9 144, so 16 times, and 16 144 9 times. Numerator is y minus 3 whole squared, RHS is 1. So this is the what is called the extended basic form, completed square, and completed square helps you to arrive at the center coordinates immediately. X minus h, therefore h is 2, and y minus 3 compared with y minus k, therefore k value y coordinate is 3, so we get 2 comma 3 as coordinates of center. And you can see the orientation of the hyperbola. The x minus 2 whole squared is the positive term, 16 in denominator, therefore a square is 16 and a is 4 and b squared is 9. Unlike ellipse, we cannot judge by the larger value by comparing magnitude, because in ellipse we are sure the major axis is always larger than minor axis. But in the case of hyperbola, you can have transverse axis longer than conjugate, or it can happen the other way around, vice versa. Okay, so larger number does not decide the transverse, rather positive term decides the larger, and that decides, not the larger, transverse axis. Okay, keeping the RHS positive 1. Keeping the RHS positive 1. Okay, so sometimes in competition they trick the students by changing sign everywhere. So you have to be very careful. Keeping RHS positive 1. In LHS, whichever is the positive term, that decides the orientation of the hyperbola, and denominator holds the value of a square. The orientation, everything you can find. Fine. Now let us proceed to find the other coordinates. Let us say the question is like this. Your task is to find vertices, foci, directrices, eccentricity, and length of latus rectum. So let's go for the 5 parameters. So number 1, vertices. So vertices, that is A and A dash. Orientation, we have confirmed that transverse axis parallel to x only. Okay, so vertices will be, y coordinate will not be changed. Center, take the center 3, it is not changed. So first let us calculate. H is 2 and vertices, so A units you have to add. Similarly, A unit you have to subtract. So it is 2 plus 4 or 2 minus 4. So it is 6 comma 3 and negative 2 comma 3, which are the vertices. So that is for A and A dash. Well, so once that is done, you are ready to find foci, and to get foci you need the value of C. So C square is A square plus B square. Very simple, A square, B square, you can simply add. It is 16 plus 9 giving you value 25. So C is square root of 25. Consider positive answer, because anyway you are going to add and subtract. Okay, so the foci F1 and F2. Okay, so y coordinate 3 will remain unchanged. So what you will do is modify the x coordinate 2. So it will be 2 plus 5 and 2 minus 5. In other words, it will be 7 comma 3 and negative 3 comma 3. So these are the foci. 7 comma 3 minus 3 comma 3. Okay, I hope students understand. It's very easy. You just have to move the coordinate forward and backward, or say to the right and to the left, to get the foci coordinates, to get the vertices, and to get directrices also. And here we know the directrices, because it is a transverse axis parallel to x-axis. So directrix parallel to y-axis, having equation x is equal to h plus or minus a by e as indicated here. H plus or minus a by e. So directrices we get x is equal to h value available from here, x coordinate, plus or minus a value available 4 by e value. Okay, so that means e value we are yet to get, which is c by a again. So 2 plus or minus 4 times a by c plus or minus of 4 times a is 4 by c is 5. So it is 2 plus or minus 16 by 5. So it is 5 LCM 10 plus or minus 16. So that makes 26 by 5 or minus of 6 by 5. So you can say x is equal to 26 by 5 and x equal to negative 6 by 5 form the directrices. They form the directrices. So once you are done with directrices, the last one, eccentricity, was already found here actually. So this terminology, this is E, C by A, C is 5, A is 4. As you can see, always just confirm once again, conceptually the eccentricity of hyperbola is larger than 1. Please confirm it. So there is no error. Then the length of latus rectum, LLR, expression, very simple expression, it doesn't change, and 2 times of b squared, yes, 9 here, a value is 4, so it is 9 by 2 units long, length of latus rectum. So this simple example I took as an guideline, so that you will be trained in analyzing the geometry. First completing the square, get the center coordinates, and thereafter you move the x coordinate right and left by adding a units, you get vertices, add and subtract c units, you get foci, add and subtract a by e, you get directrices, LLR, eccentricity. Okay, so this is the way you will be able to answer quickly in case of MCQ also. So with this, I think the basic geometrical concepts have been covered. Let us meet in a different problem solving session. Thank you.